So this is 1.3 comparing speeds. This is page M214. We are continuing the problems from last time. So remember we were talking about Dasa. She went 60 miles per hour. Timar went 50 miles per hour. So we said that Dasa was going the quickest. Now we're going to look at Alicia. So Alicia's is an equation. So if we look at her equation, the y equals 57x, when you're looking at an equation, let me use orange. So this is our equation, and it is y equals 57x. So in the equation, this 57, what you would have seen before in 7th grade is that this is a proportional relationship. Okay, and I'm going to use pencil and underline that stuff. So it's these are all proportional relationships where we have the constant of proportionality. And so if we look, the k is the constant, which is also identify the constant or rate of change. So constant of proportionality and rate of change are the same thing. So we the other day, or in the last set of notes you put constant rate of change. I want you to put constant of proportionality is the same as rate of change. So hopefully you remember that word from last year. If you don't, that's okay. We're still going to be learning it just the same. So the constant of proportionality, or the rate of change, is the k in the equation. So is the k in the equation y equals kx. And I'm going to highlight that. So the k is the rate of change or the constant of proportionality. So we're not going to talk about or use the words constant of proportionality very much. We are really going to be talking about rate of change. That is our big thing that we're going to be talking about. So rate of change is the k. So if we go back to that problem that we just looked at, it's actually a lot less work than what we had to do up here. Up here we had to divide the 50 by 1. In this equation, it already gave us the rate of change. So the 57 is our rate. So you can know that Alicia went 57 miles per hour. So Alicia is going 57 miles per hour. Okay. So then if we look, who actually went the fastest? So we know who went faster out of Timar and Dasa, but who went the fastest out of all three? So we had 60 miles per hour, 50 miles per hour, and 57. So the final answer for that is Dasa again. She went 60 miles per hour. All right. Now, on this, I want to write a few more things with that. So this is actually called the coefficient, and that just means the number with x. So the coefficient is that k. So I know I just said a whole bunch of different things, but always remember that the coefficient, or the number with x, is going to be our rate of change. Later on, Later on, we'll start having extra stuff on this equation. So if you just get in your mind now that the k is the coefficient or the number with x, then you will be completely fine. Okay, so the coefficient can also be a fraction. Can be a fraction or a ratio. Don't let those words freak you out. But if we were going to find, so if our example was find the rate for y equals 1/2 x, our rate would just be that 1/2. So our rate is 1/2. So they might be going half a mile, or they might be going half a foot a second. I don't know, just some, they might be charging you. Later on we're going to talk about like they're going to charge you so much money. So they might be charging you $0.50 for something or 50 cents. So the rate is 1/2 or 0.5. So they can be decimals, they can be fractions, just whatever numbers with the x is always going to be this equation, or is going to be the rate in the equation. So what I want to do now as an example is if we were going to look at DESAs again and we wanted to write the equation. So down here I'm going to write the equation. So in this case, we know what the rate is, so let's write our equation. So our equation would be y equals 60 is our rate, so we're going to do 60x, and that's it. That is our equation because we took our rate and we placed it with x, because that is what we use for here and here. Okay, now let's write our equation for Timar. So Timar's equation is y equals, his rate was 50, so we're going to do 50x. And that is our equation. So in your assignment, when you're writing your equations and everything like that, you're going to be comparing. So you're going to compare and say, like if you were looking at this equation and this equation, who has the faster rate? You would look at the 50 and look at the 57, and you would say which one is greater, and that would be 57. If I said which one had a slower or less rate, I can't talk apparently, I would say the 50. So just pay attention to if it says more or less.